So shall we start with some introductions now? 203. Okay, great. So welcome everyone to the first of our 2021 Invasive Species Lunchtime Talks series. I'm Sabrina Drill, one of your co-hosts for the series. I'm a natural resources advisor with UC Agriculture and Natural Resources, specifically cooperative extension in the Los Angeles and Ventura County area. And I will be your moderator and host today. If you, as you have questions for the speakers or questions sort of about the substance of talks, please go ahead and put those in the Q&A. If you need any kind of technical assistance, we've got some folks monitoring the chat, so go ahead and put those in there, and that would be great. Otherwise, get settled in. I think that because this is a webinar, everybody will be muted anyway and not be sharing screens other than our panelists today. So I just want to give a quick introduction to UC ANR. We're the University of California Division of Agriculture and Natural Resources. And we have offices in every county in California through the cooperative extension system. We also run the Master Gardener program, the California Naturalist program, and the sort of spin-off from that, UC Climate Stewards, as well as 4-H and a whole variety of nutrition programs, programs working directly with growers to improve the sustainability of agriculture around the state, forestry, et cetera, et cetera. I'm going to hand it off for an intro to one of my frequent collaborators, the California Invasive Plant Council.
Thanks, Sabrina. Yeah, we're thrilled to be partnering again on this Invasive Lunch webinar series. My name is Doug Johnson. I'm the Executive Director of the nonprofit California Invasive Plant Council. And we do a lot of work with the UC Division of Ag and Natural Resources and lots of other partners across the state. We have an annual conference, the Symposium, which is coming up this October. It's our 30th annual. It will be online, so it's relatively cheap and easy to attend. Our membership comprises land managers, researchers, businesses and agricultural producers, as well as volunteer restoration stewards, all interested in invasive plant management across the state. We maintain a list of invasive plants in California, the inventory, and we have a resources library that has lots of best management practices, manuals, and reports on a variety of topics. The most recent product is completed in partnership with UC ANR, and that's a set of best management practices for controlling weeds with non-chemical methods, and an online tool that will help you select amongst those methods for your particular situation. So feel free to visit our website. Lots of free and useful resources available there.
Great, thanks Doug, and thanks to the whole team from CalIPSI who's helping us with this today. I also just wanted to mention that this series is part of California Invasive Species Action Week, which is pulled together by the California Department of Fish and Wildlife every, I think, second week in June or around there, but it's for a week in June every year. And in addition to this webinar and other educational events, there's also chances, especially on the weekend, to kind of get your hands dirty and volunteer at some events going on to manage invasive weeds. And with that, invasive species overall. And with that, let me introduce our speaker for today, Dr. Ted Gersholz. Ted is a professor and Alexander and Elizabeth Schwantz, hopefully I pronounced that right, specialist in cooperative extension at UC Davis. He's a benthic marine ecologist who works on restoration of coastal habitats and the impacts of aquatic invasive species and climate change on coastal ecosystems. He's a member of the National Research Council, and he's co-authored the National Plan for European Green Crab Management and the California Aquatic Invasive Species Management Plan. So thank you, Ted.
And Ted, are you able to, I stopped sharing, are you able to share your screen?
Yep, I'll go ahead. So thank you very much, Sabrina, for that nice introduction. So I'm going to take this away if there's no other issues and share my screen and start my talk.
That sounds great.
Okay, welcome everybody. So I'm Ted Gersholz. I'm a professor and a CE specialist, proud member of A&R, as Sabrina mentioned. So I'm going to talk a bit about some of the work that I've been doing and my colleagues about managing invasive species, and in particular, as you'll see by the end, how community science can play a really key role in managing invasive species, in particular, an example from the invasive European green crab. So the goal for many or most of us is really trying to protect against the impacts of biological invasions. As we all know, they're ubiquitous in many systems. Of course, the systems that I work in are aquatic, estuary, marine systems. Here's a list of some of the really most important invaders. I'll be focusing on the European green crab here. It is, as you'll see, one of the 100 worst invaders. Interestingly, a couple are missing. So lionfish, which I think is probably the worst invader in the oceans, isn't even on the list. So there needs to be a bit of updating, but green crabs are certainly there, and they're an important species and concern for California and the West Coast. So what about this species? So it's had substantial impacts on native fauna, benthic species across California. It has had substantial impacts on fisheries. In particular, it still is responsible for about $20 million every year of fisheries losses on the East Coast, mostly commercial shellfish. And as I mentioned, it's really amongst the 100 worst invaders on the planet. It's in part because it's such a good invader. So here's a map of where it is currently has invaded. So these red areas are invasions, and you can see, in addition to being native to Europe, it's established on both coasts of the US, South America, Africa, Australia, also elsewhere in Asia as well. And it continues to move along the West Coast. So it came into California late 80s and has spread up the West Coast in the sort of preceding, following decade. And I want to point out it continues to move. So it's continuing to expand its distribution northward. This are our data from colleagues, Tom Theriault, Steph Green, and others. And this is as recent as May of 2018. You can see these red dots show that it's continuing to move up the coast of British Columbia. Hasn't reached Southeast Alaska yet, but will be there probably soon. So my talk today is really going to focus on sort of my work and how I think about these invasions, and I think lessons for management and based on some of our failures and some of our insights. So part of this is really understanding what drives invader populations and how that should or could inform our efforts to try to control some of these species, how to mitigate some of those impacts. And so how can we reduce or eliminate that species with the goal of trying to sort of bring back ecosystem functions, services, or just something as simple as native species, possibly endangered species, possibly commercial beds. So what's really at risk and what can we mitigate? Then, of course, understanding management limitations. We don't have unlimited budgets to do this. So what resources are needed for these kinds of efforts? And as you'll see, as we'll bring in community science and volunteers, how we can better meet some of these management limitations. Oops, excuse me, wrong button. So here's a roadmap for today's talk. It's going to be coming into 3 parts. The first will be our efforts to eradicate the green crab, and I think some really, really important lessons for others involved in eradication efforts. Secondly, as you'll see, we failed dramatically, and we've now developed an approach, and I'll explain this in detail, about for functional eradication. The idea here is there's a lot of difficulties and risk of trying to reach full eradication, and you may be able to reduce populations enough to bring back what you're looking for, native species, ecosystem functions, commercial shellfish production, whatever it is, with reasonable targets. And we go into great detail about how to develop those targets. And then lastly, the use of community science to provide the capacity for this. So if you're going to be undertaking an extended eradication program, you need to be able to undertake that and have the capacity to do this over some period of time. So we'll talk about how to do that as well. Okay, so to start with, we all realize that preventing invasions is by far the best strategy. I mean, we completely understand that. I've worked quite a long time on non-ship-based methods of introductions and continue to work on this, but unfortunately invasions continue to show up. So even though we try to prevent eradications, there's still the need for programs involving eradication, containment, control. So the goal is, under what circumstances would eradication or containment be successful and be the best approach to managing a really problem species? Okay, so I'll be talking about European green crabs, which I just showed you. And of course, you saw the distribution along the West Coast. So no one is under any illusions that this is going to be eradicated anywhere. So certainly not, except for small places, even with new tools. But what we did is we undertook a local eradication program, you'll see in a very localized place, to quantify what sort of investment and effort would be sort of successful in some sort of future program. So we did this thinking about a situation. You saw the map of Southeast Alaska and British Columbia. What if we found a population hundreds of miles from the nearest other population, probably not very well connected, might be a very small, newly detected population? Could we go in and eradicate that small, recently established population? So this was, in a sense, a proof of concept. So we conducted this in a marine lagoon, Seadrift Lagoon in Marin County, which you'll see is a small location, a small body of water that has limited hydrological connectivity. So it looks something like this. This is in sort of just north of San Francisco. I'll show you a larger map in a bit. This is about 50 miles north of San Francisco, 60, 70. So it's a roughly 2 kilometer long body of water with connections only at these blue arrows. So it's only very seasonally and has very limited connectivity to Bolinas Lagoon, and then the outer, the larger West Coast Pacific Ocean ecosystem. So what did we do? So with funding, as you'll mention, from Pacific States Marine Fishery Commission, Stephen Phillips, we undertook a very intensive trapping effort. So this was 15 baited fish traps at 6 sites. So that's 90 traps every day for 3 consecutive days for 3 to 4 weeks throughout July and August. So this was quite a lot of trapping effort to try to remove these crabs. And so we did this continually for a number of years. And you'll see, I'll show you exactly what the data look like. This is sort of what a typical trap might look like, although in some places and sometimes this could be entirely full. We might actually get up to 100 crabs in a single trap in some very high abundance years. But this would be sort of a typical dozen to dozens of crabs per trap. So what happened? What did we do? Were we successful? Well, for 5 years, you can see here from 2009 to 2013, we were very successful. We reduced the population to below or less than 10% of the initial population, which probably had been there for a number of years. Only to find that suddenly in 2014, the population exploded. So we had nearly as many crabs as we started with. And I'll come back to this. We've since fished it down. I'll continue to talk about how to maintain at a lower level in the future. But I just want to focus on, for the next part of the talk, on what happened here. So what went wrong? We were fishing crabs out and suddenly there are all these crabs left. So you'll notice from the size distribution, almost all of these are juvenile crabs. Well, it turns out we shouldn't have been so surprised as we were. There's a lot of ecological theory that suggests this may have happened. This is a paper literally published in the year we started that shows this overcompensatory relationship where there's reasons to think, and there's actually model results to show that as adult populations get smaller, this left side of the x-axis, you can actually get increased survival, growth of juveniles, you actually may get this inverse overcompensatory relationship. So you may be increasing recruitment in our case, as you're fishing out the population. There's also a lot of other models. There are fisheries models that go back to the famous Ricker fisheries model of 1950. There were papers written by Peter Abrams calling this the Hydra effect, where for every head, if you remember the mythical Hydra, for every head you chop off, 2 more grow back. So this beheading the Hydra is very, kind of much of what we were doing. But this idea that you may get sort of this unexpected result is due to this overcompensatory reproduction. So again, this was expected to some degree, at least in the models. And interestingly, as we pawed through the literature, we found that this had been shown for other invasive species removal actions. Unfortunately, none of these were really very experimental efforts. They were usually sort of after the fact, oh my gosh, what have we done? So in this case, for instance, there was a 7-year removal of smallmouth bass in an upstate New York lake where they ended up with more smallmouth bass than they started with. Again, because this increased the abundance of juveniles, gave them more food as adults were fished out. But the same kind of result has been shown for a number of different other species, many fishes in different parts of the world. So there have been a lot of accumulating evidence suggesting that maybe this wasn't such a surprise after all. So what happened in our case? What was the mechanism? What created this population explosion? Well, here you can see this little stage here. This is a recent settled instar, a little tiny crab here, which is yummy, munchy for all the adult crabs. Of course, they didn't all look like this. This is a group of crabs in a trap in a box, but they easily eat the small juveniles. And it turns out this is very common for a lot of species, for crustaceans, many of them, a lot of fishes that eat their offspring. Large fishes eat small fishes. They don't particularly care or know whether it's their offspring or not. So this kind of adult consumption of offspring is very common throughout many species in the aquatic world. So our data suggests that this was due to the failure of adults to control juvenile recruitment. So what we had done is we fished down the adult population to a point where they failed to control recruitment, because usually the adults would run around vacuuming up most of the recently settled juveniles. Well, we prevented that by fishing the adult population down too far. And many models show that this can create what's called a stage-specific overcompensation, which I won't get into. But one of the predictions would be that this would be due to the size-dependent consumption, because obviously the little ones aren't eating themselves or they would disappear, and the adults clearly don't eat themselves. So adults don't consume other adults, but we needed to show that the adults consumed the small ones. And I won't go into detail here, but we conducted a number of tank studies. Colleagues of Robert Tiburon, who'd like to thank, many replicates run many times over a summer period, providing data that looks like this. And this is sort of the key result, so that as the difference in the adult versus the juvenile size ratio increases, so as you go from left to right along the x-axis, the difference between the crabs gets larger. So you have bigger crabs and smaller ones out here. And that increases the likelihood of cannibalism, showing that the size ratio really is key to what we saw in Seadrift Lagoon. Some of the other information we had surveys at 5 regional bays over the same period. And here you can see where Seadrift Lagoon is located in Stinson Beach, just north of San Francisco Bay. But we had trapping data, similar kinds of trapping data from Bodega Harbor, Tamales, Bolinas, Elkhorn, and San Francisco Bay at the same time that we were undertaking this removal in Seadrift Lagoon. There were no removals in these other bays. And here's what the data look like. So although and I want to draw your attention, this is a log scale. So this is actually a very large increase, which you saw before. Unlike Seadrift Lagoon, there really weren't any changes in any of the other bays, suggesting that there was nothing about oceanography or warm days or something that was affecting these. It was very specific to Seadrift Lagoon. The other part of this is with colleagues Carolyn Tepholt and a few others, but Carolyn was clearly the leader with this, and her publication coming out soon, Molecular Ecology. We looked at populations up and down the West Coast. And just to look at this, I won't bore you with the details. Look at the pink color here. You can see the pink colors. This group of pink spots over here on a PC axis shows that Seadrift is extremely diverse. So these are the shapes are different years and are very different than all the other crabs along the West Coast. So Seadrift Lagoon has very distinct genetic signatures, indicating, strongly supporting the idea that it's very localized, very isolated. So what happens in Seadrift stays in Seadrift. So what we saw was not the result of influx of larvae from other sites. It wasn't because of recruitment in other places. What was happening was entirely due to our efforts and not something external. Okay, well, the sort of the mop up from this is that our eradication program succeeded very well for 5 years. So if we can sort of stopped after 4 years, we'd have said, well, we're being pretty successful, maybe we can walk away. And then we had this catastrophic failure. So it's really a first experimental example of a removal-driven overcompensation. So we found something important, but it wasn't what we wanted to find. We found no evidence of any similar increases in any of the other regional bays. So we were actually lucky to have been conducting this for very different reasons alongside the Seadrift removal. Again, one of these examples where sort of unexpected collaborations and data sets you hadn't anticipated being very useful turned out to be very useful. This loss of adult control via cannibalism is the most likely mechanism so that we have a good understanding of what happened. Well, you also point out that this isn't specific to green crabs. Again, many other aquatic species undertake this. So this particular mechanism could work in a lot of other systems. And that the population's isolated so that we're not likely to have like fallen victim to some sort of unexpected influx of larvae. So here's the publication, as I mentioned. So you can go look up all the details here. And it's a PNAS article that was just recently came out. So you can look up some of that. I think all of these paper links that I'll show you are in the chat. So those are available. And I just want to thank my co-authors for this part, Greg Ruiz and Kat de Rivera, who were extremely important collaborators through all of this. Many other folks, Linda McCann, many others at CERC who were critical to making all this work happen. NSF and Pacific States Fisheries, and you'll see Greater Farallones later for some of the other work, Kate Bimrose and Karen Niederberger. So lots and lots of people contributed to this because it was an enormous effort to do all that trapping. Okay, so now I want to switch gears and move on to the second part. So I want to sort of conclude that eradication or full eradication comes with a lot of risks. We just demonstrated one of these. It's extremely expensive, and we can have this discussion a bit later on, or we can answer any questions. So then what? It's like, okay, well, you sort of dashed that option. Now what do we do? Well, what we will argue is that functional eradication, which I will explain and define, is a better approach to this. And the idea is that to reduce the population, not to the point of removing all of them, but reducing the population to a size where you begin to recover whatever it is that is at risk, whether it's native species, endangered species, some MPA characteristic, potentially commercial shellfish beds, or whatever happens to be at risk for that species. So to take a step back, so when is eradication actually most likely to succeed? Because I know you're sitting there going, well, gee, we've eradicated a lot of terrestrial plants. I don't see what the problem is. And it's not to say eradication with many species can't be successful. It has shown to be very successful. So things when you have restricted geographic ranges, maybe islands, very small population sizes, habitats that are readily accessible, like a grassland, invaders like this that are very easily identified and removed, trapped, whatever. Those are places and like situations where eradication may very well be successful and has been very successful in the past. For a lot of aquatic systems of different kinds, you can imagine an open ocean system, or you can imagine this sort of estuarine system with turbid waters and this enormous network of channels, and you can't even see where and what's in there, let alone be certain you've gotten rid of everything. So there's a lot of challenges in some of the coastal systems that make eradication extremely difficult. So just a sort of a framework for this as a basis. So what we've done is sort of just, I mean, you've seen the stage of evasion figure many times, but I want to sort of highlight where the information can come in that could help with this. So if you have, this is geographic extent in the early stages of invasion, you can see little spots here, all kind of contained within a smaller area. And of course, you know, probably depending on the species, developing targets for eradication makes sense. But certainly for species where they've gone beyond sort of a containment or a suppression, excuse me, they've gone beyond the area that containment or suppression is really going to have to be the strategy that we move into when we have sort of limited abilities to try to reduce the populations or develop smaller areas that we identify, whether it's an MPA or a small area, then we can maybe perhaps be successful with this. But one of the things that I want to focus on is two things. One is that this idea of local suppression or functional eradication necessarily will involve high priority locations. We can't expect to undertake this along the whole West Coast or even a small part of it. So the idea is that these are places that are high priority for various reasons. There could be an endangered species, it could be a specific MPA, it could be of commercial value. And then the goal is, well, what does success look like and how do you estimate what those targets are? That's really the key thing. What's the goal for that management program? Well, one of the things we did to try to answer this, and again, I'm going to credit my collaborator, Dr. Stephanie Green, who was absolutely instrumental for this and actually undertook the mechanics of the survey. We put together this survey that looked at the invasion status and what was being undertaken for priority ANS species, aquatic nuisance species across the US and in Canada. So to understand management goals and interventions, to find out what were people doing, were they undertaking eradication or control or suppression, what was actually being done, and getting perceptions of available resources and how they were going about this, what was available to them. The target audience, again, was any management, government, federal, state, local levels, mom and pops, NGOs, private sector, in the US and Canada. So this was sent out to lots of different folks. We started with ANS task force panels, Western, Northeastern, Midwest, et cetera. They were very good starting points for sending out this survey. So it was an online survey completed within about 15 minutes, so it wasn't onerous, involving snowball sampling to try to expand the reach of the survey. And to our surprise, we got almost 250 respondents. So a lot of folks working on AIS wanted to see this. And again, we've been pretty good about, I'd say very good about getting the results. We've gone to several panels. I'm going to be talking at the ANS task force meeting in June to again provide some more of the details about this. What exactly did managers respond with? But we got lots of different respondents from lots of different folks, and including Canada as well. This just shows the US ones, but it was actually quite good that we got these back. So what we found is, out of all of this, so this binational survey showed that about 60% of the invasions that are currently being managed, that are viewed as priority invasions, are occurring at a scale beyond the resources available for eradication. So many of these, you know, the horse is out of the barn. There's just not really a future for any possible eradication. So many of these programs are undertaking some sort of control suppression, but most of these lacked any targets. So when we said, well, what was your target for this? What were you using? Almost all of them said, well, we don't have targets. And part of this is the point I'll make throughout this, and I don't have the time to go through this in the data, it's in our paper, but many managers actually have the data to develop these kinds of targets. And I'll sort of explain what this looks like in a second. So the idea is to back away from eradication and move to suppression. And many groups are doing this already, but the idea is there's a good reason to really try to move towards this in many or most situations, in aquatic situations. as a way of making more effective use of resources. So what we need to do is set ecologically informed targets, and I'll show you how in a second, to go from this numerical eradication to a functional eradication, to get the population down to a level where you begin to recover the whatever is at risk, whether it's native species, particular MPA values, endangered or threatened species, commercial species of value, et cetera. So the key question to be able to do this is what level of control is required to alleviate the impacts, and how much effort is required to do this, and where should this be done? Which areas should be prioritized for these kinds of efforts? So we in our paper, we go through this in 3 steps, and this is where I want to sort of emphasize that there's data in hand to do this. So quantify the mechanisms by which the invader affects communities. So in most cases, managers know, like, okay, well, what's at risk? I mean, okay, we're looking at a couple local native species. We see they're declining. We're worried about this species changing the habitat. Maybe it's an invasive plant that's changing a mudflat to a salt marsh. There could be lots of things. So typically what's happening is often known by the folks, kind of responsible for managing this. The second one seems like it may be more difficult, identify the threshold that'll elicit the proper changes, but 2 things are being gathered by many, or well more than half the managers in this situation, is some sort of survey, if you will, of the invader. I mean, typically the only reason an invader is becoming a problem is you see the abundance is increasing, and that's one of the basic metrics that many groups are using. It's like, okay, well, we go out and do an annual survey, so we know it's getting more dense. We know that the area is increasing. But then the other part is that typically there's some other measure, not always, but measure of whatever may be at risk, a native species, a threatened species, a commercial shellfish bed. So there's often a measurement of like, well, what's going down while the invader is going up. And that's really all that's needed as we go through for setting a population threshold. Okay, I want to do this very graphically and move quickly through this, but it makes the point, I hope, is that here we'll do this for European green crabs, and I'll explain this graph here. This is CPUE, this is what you were seeing earlier. This is called catch per unit effort. So for a lot of aquatic marine species, direct measurements are very difficult. We actually do mark recapture studies, which I can talk about later, but this is a relative measure, catch per unit effort, very frequent. As this will increase as densities increase. And this is recruitment on this lower graph here on the y-axis. So this is recruitment as you see adult population size increasing. The upper graph shows whatever the change is in this case, native shellfish, but it could be native species, it could be something else, whatever is of interest. So the issue is, if you have just a linear relationship, so as green crabs increase, recruitment goes up, and as green crab increases in the upper graph, that the native species goes down. If it's just a linear relationship, then there's no threshold. More is better, and there's no target really. Just as much as your resources you can throw at it will work. But what we found with this species, but also there have been syntheses showing that these nonlinear relationships are actually the rule. So for wherever data has been available for this, relationships like this are much more common than a linear relationship. So here you can see for green crabs, as green crab abundances go down, you can see the proportion change in shellfish goes up. So you're getting more shellfish coming back, but there is this sort of plateau. And then this here is green crab on this axis, and you can see this is the reproduction. That's that functional, that's that overcompensatory reproduction that we saw before. So this is what happens when the green crabs actually get too rare if you overtrap them. So what this means is you can identify a range, and while we've done this for green crabs between 10 and 20 CPUE, that's sort of it's a kind of a proxy for density, which would reduce most of the impact on native shellfish, beginning to get to that plateau area, as well as reducing green crabs, but avoiding that very, very low density where you start to get that unexpected overcompensation. Now you're thinking, okay, that's great. We had 10 years of excessive data. And so this must be specific for green crabs, but we found we did this in our paper for 2 other species, for lionfish and for rusty crayfish, and we were able to identify similar kinds of targets for suppression or control to basically bring back native species that were in those areas. And this kind of threshold can be done for lots of other species. So this kind of information, as we show in our paper, is doable. It's reachable. So this provides a reasonable target and for the functional eradication. So in many systems, eradication is not a possibility. Certainly in many aquatic systems, just absolutely off the table. It's certainly not a good option in species where overcompensation is a possibility. So for lots of species, fishes, crustaceans, many others, where adults consume juveniles and there's this adult control of recruitment, this is likely a situation where this may happen. We can talk about connectivity, populations. Of course, that's very important. Our paper makes that point. I also want to point out that even if you were really successful in eradicating a species, you can still have reintroduction even after you've eradicated. We've seen this with Ascophyllum in San Francisco Bay. Interestingly, in Southern California, one of the most successful eradications, Chlorpa taxifolia, has now resulted not in taxifolia reintroduction, but another Chlorpa species has come into Southern California. So just because you've eradicated doesn't mean you can pick up and walk away and never return again. Functional eradication can allow recovery of native species, abundance and ecosystem functions, and the targets can be determined from available data. But of course, there are costs to this, and we'll come back to this in a second. And folks out there in the audience are going, okay, let's see. We eradicated the species and we can stop doing this, but this functional eradication seems like it demands continual work year after year after year. And yes, that's the case. And the question is how to do that. And the third part of my talk, we'll get to that specific issue in just a second. I do want to thank my participants in this. Again, Dr. Stephanie Green at University of Alberta, who's been absolutely critical and a major driver of all this. The staff of the regional panels who were really super helpful with getting our surveys out. Mark LaBelle, my colleague at UC Davis, and his students for help with the survey language. Sending out surveys is a intellectual endeavor in itself. And many resource managers and others who responded to our surveys. Here's the paper if you want to look up the details. There's also links to the survey data here, recent paper in Frontiers in Ecology and the Environment in March. Okay, so how to do this? Okay, so Ted's told us that eradication is risky and may fail. He's made this pitch for functional eradication, which seems like, okay, well, maybe you can do this, but how are you going to get this done year after year after year? Okay, so the pitch I will make is that, as we have found in limited situations for high priority species, community science and volunteers can provide the capacity to make functional eradication a reality, or at least for some period of time. Now, of course, the equation, whether or not to undertake this, requires balancing a lot of different variables. How vulnerable the system is to a particular invader, the value of that, and that could be in terms of native species, and species at risk, endangered, threatened species, how feasible it is to even undertake any sorts of management actions, and how sustainable it can be. How can you manage, or how can you continue this for any period of time? Okay, so what we were able to do, and I'll thank lots and lots of people that assisted in this, was to bring in local folks, community scientists, and just volunteers to undertake this really very labor-intensive work and continuing to do this into the future. Here you can see just sort of a backdrop of Seadrift Lagoon. But the idea here is we had a lot of effort, and this was, and I would say, and I clearly spelled this out, this is a high priority area that people care about. And I don't make any I don't pretend that this is going to be a solution for larger areas or for lower priority areas. So of course, this does require an interested local group to undertake this and to make this happen. And luckily, these were folks that really helped to make that, even just the scientific part that you saw happen. We never could have undertaken that level of trapping effort without a lot of help. The original group of volunteers was made up of local homeowners, literally provided by the Homeowners Association. And they provided kayaks, dock space, long-term use of their property. People were very generous, allowing us to come in with like this horde of people and get set up and spend hours and hours out there to do this work. Then we got the Greater Farallones National Marine Sanctuary, which used to be Gulf of Farallones. I'll slip into that every now and then, to be engaged in this process. And they brought along with them their impressive list of volunteers. The National Marine Sanctuary has a great long list of volunteers that also contributed to this effort, as did some summer groups locally, camps and other school groups and so forth. And we've had a number of different groups participate. Just as an example, in the last year or two, we've had 57 members that put in 460 work hours over this. And we still have about 40 people that get regular updates. So we have a group that's really tuned into this and are continuing to do this. And I don't step away from this saying, oh yeah, this is easy to do. There's a lot of burnout. There's a lot of needing to continually recruit new people, because people do this for a while, then they get bored and they're like, okay, I did that, off to something else. So it's not the same group of people. It needs to be continually recruiting and gathering new people to help with efforts like this. This is kind of what this effort looks like, just to show you we haven't really fallen off. So here you can see trap days for every year, remembering we have 90 traps. So like over the course of a week, that's like almost 300 traps over a 3 to 4 day period. This is our catch per unit effort, which you saw before. And I just want to sort of, if you take the one and divide the other, this gives you an idea about our relative trapping effort. So we're able to continue to maintain this trap effort. And we do have data for 2019 and 2020, which I don't have listed here, but this continues into the future. So our goal here, this is the graph you saw before, is now to focus on what do we do now that we've seen this explosion? What's the goal? What's the program? So it's really changed from a reduction program to a program that seeks to maintain this reduced population size. So we have data from 2019 and 2020, which I haven't put on this graph, but it's effectively the same thing. So now we're into 4 and almost 5 years of maintaining the population at this very reduced size. So it's about 30%, 20 to 40% roughly, about 30% of that initial number. And it's also involved continuing to do annual mark recapture studies. So in addition to the CPU data, which is crabs per trap per day, we actually have actual population estimates. And what we do is we take crabs like this. It's a little hard to see, but you can see spines here and not spines here. We actually clip off some of the anterior lateral spines so we can kind of keep track of marked crabs and identify year classes. And volunteers continue to help with this too. So we're gathering a lot of data on the crabs, so we're finding population changes as a result. Okay, so to begin to tie this up, it's a program that's changed from really a management proof of concept to sort of a scientific inquiry when we were faced with completely unexpected results, to now a longer term management program that's driven by interest by Greater Farallones, by the Homeowners Association, by all the volunteers. So it's the importance of community understanding of the underlying issues, as well as just the immediate goals of removing crabs. So we're hoping to sort of increase awareness and understanding of this particular project, like where is it going and why are we doing this, but also use it as a tool for a more general understanding of the threats posed by marine invasive species. Because here it's in their backyard, but people need to know that these are, very common in many different places. So the management goals are, as you saw, to try to maintain crabs at a low density, maybe 20, 30, 40%, but avoid reducing it to below 10%, which produce that overcompensation. So we're trying to find this sort of Goldilocks region, which seems to be working so far. and then working to sort of better measure ecosystem function and species recovery as we continue to move forward with this. Okay, just to finish up here. So overall conclusions, we show that eradication can fail dramatically, and we make the plea to move towards functional eradication and try to provide ways in which that can be done. Managers often have and really frequently have the data needed to come up with reasonable suppression goals, and we provide some sort of guidelines for how to do this. Clearly, this is only going to work in places that are priority situations, limited, sort of places of limited, maybe connection control, places that have real issues at stake, native species of concern, threatened endangered species, commercial value. And of course, this requires a lot of work. So community scientists and volunteers can really expand the scientific and management capacity as to make this work, but as well as increasing public awareness to make it clear why this is important and worthwhile. And so critically engaging community scientists, we have Kate Bimrose, who's been really managing the data and basically roping together the volunteers for recruiting and training project volunteers. So it's been absolutely essential to moving forward with this project. Okay, just to finish, again, this third part, here's the publication. I see Sabrina's name on this publication as well too, in California Agriculture. So again, we have links to this paper as well. Okay, so just thanking lots of folks, Kate Bimrose and Linda McCann, Karen Niederberger, the folks at Smithsonian, San Francisco State, California State. So lots and lots and lots of different programs, lots of volunteers, because none of this can happen with a small handful of folks. So lots of contributors. Okay, I think I'll stop there and thanks and take questions. That's me. Okay, so Sabrina can hopefully hop on or Doug, and I will stop.
Hi.
Here we go.
Yeah. Thank you, Ted. That was a great presentation. And wow, it dawned on me what an exemplary extension specialist you are, really. From the research to the community engagement to the management implications. So thank you.
I've learned it all from you, Sabrina.
We worked together for a long time, folks.
Yeah, I just want to make a pitch. I mean, this is a good pitch. I mean, me as a campus specialist and Sabrina as, a county advisor, I think this is an absolutely wonderful example of how the A&R network should work. And I think this is a really, really great example of that. Sorry, a little bit of self-promotion,
Yeah.
but I think it's an important.
Yeah.
Hey, Sabrina, can I kick off with a couple general questions?
Yes, please.
That'd be okay. Thanks, Ted. That super fascinating how you could remove a bunch and then have the population explode on you. So I guess two major questions. One is, what the heck do green crabs do that's a problem?
So am I still on here? They do two things. I covered that early in the thing. So they have huge impacts on native species. They basically reduced native crabs and native clams by about 90%. This is an important part of the food web that supports shorebirds. We have data to show that the shorebirds' diets have shifted dramatically as a result of this. They have huge impacts commercially also. So on the East Coast, they decimated the soft-shell crab fishery in the early part of the century. They continue to have major impacts. And shellfish resources become more and more important as you get farther north, as you get up to Washington and British Columbia. And the numbers of green crabs in British Columbia are actually approaching the numbers we've had in California. They didn't really accumulate in say, Oregon, Washington to what we expected. But so there's a real potential for impact on commercial benefits as well. So, but huge impacts on native ecosystems and huge impacts on commercial ventures, if you will.
So they just chow down basically, and they're not natural enemies that are keeping them in check.
No, so just very briefly, it's a fairly large crab that lives in an intertidal zone. So if anyone spent time on the West Coast, the only intertidal crabs are little grapsid crabs, hemigrapsis and pachygrapsis. So it's basically a crab that has kind of a free run of the entire stretch of the intertidal. All the rock crabs and cancres are down deeper. They're not really apparent in intertidal areas. So this whole zone is something that never really had a consumer like this before.
Oh, got it. Okay, interesting. So it's exploiting
I
a
know you.
new niche.
Yeah, it's a very unexploited niche. Yes. Sorry, go ahead, Sabrina.
Yeah, I was just going to say, I know you've got another question or two, Doug, but I want to jump in with a question from one of our attendees, Nick Rasmussen, who asked, why did the local people care about the presence of non-native green crabs? Were they just concerned about the impacts on native ecosystems? And I don't know if he's asking specifically about Seadrift or more broadly, you kind of answered impacts to fisheries, but.
Yeah, I mean, sort of what's at risk in Seadrift is fairly limited. I mean, people have been sort of intrigued that they begin to see some other native species show up, but that's only a handful of folks. I think, for them, there's just sort of this notion that we would like Seadrift to try to be as, a better representative of the natural ecosystem, a little bit more like Bolinas Lagoon. They also don't want to be seen as the factory, like growing large numbers of green crabs that will then sort of turn around and leak into Bolinas Lagoon and have big impacts on that. So there's actually kind of a bit of, gee, we don't want to, be a bigger part of the problem than we already are. So that's specifically there, but I think there are a lot of people that certainly understand and care about the ecosystem impacts and the fishery impacts too. So.
And we had another question come in. What's the impact of green crabs on abalone? And I kind of want to add to this because when I think of abalone, I think of a lot of indigenous fisheries on the California coast. Were there, not in the Seadrift project, but more broadly, was there a lot of interaction or a lot of interest from tribes?
Yeah, actually quite a bit of interest in the Northwest. I mean, one of the things is that tribal involvement, at least in Central California, has been less. I mean, there's lots of reasons for that. We have some very different topic. Native oyster restoration, we're getting some folks involved in Tamales Bay from Great and Ranchery and some others. But to this point, we've had very modest involvement of tribal groups, although in the Northwest, it's been completely different. So there have been literally local tribal efforts to try to get rid of green crabs and move them out because they have shellfish interests of their own. So that becomes much more important and actually much more of a local and cultural interest. We've seen that with oysters, we've seen that with clams and lots of other things. So it's much bigger elsewhere for a lot of reasons. Abalone. Let me get to abalone. So there's not much overlap with where green crabs are and where abalone are growing. So, I mean, I spend time in the subtidal, and green crabs are not found outside of bays and estuaries. They're not found offshore. They are in the native range. And why they're not found more in California is an ongoing mystery, but no, they're not found in places where abalone are.
Now, we did have another question from John Eckhoff. He wanted to know if the Hydra effect could also be happening when folks are trying to remove freshwater swamp crayfish from Southern California streams.
Very likely, very possible. So it's absolutely something that I think is a concern and worry for places like that. So yes, it's a real possibility. It's a real risk. We'd have to see some different numbers. We'd have to know exactly, kind of what the intensity of adult consumption of the juveniles are, but that's a possibility.
And then we had some more questions from our panelists. Oh, sorry.
Nikki, I just wanted to jump in and say, if that's something that you're interested in, John, there's going to be a survey that we'll post a little bit later asking about speakers for next year. A lot of work on swamp crayfish in Southern California has been done by Lee Katz at Pepperdine. And so if that's a subject of interest, maybe we could get him in here for a future lunchtime talk series. Okay, sorry, back to you, Nikki.
Oh, you're good. We had another question from Yuta. She wanted to know, is there another alternate method to specifically control juveniles?
That's a great question. So one of the sort of the underlying things here is, people say, well, why don't you just trap the juveniles? I mean, that's a great question. But for a lot of aquatic things like this, it's based sort of like it's trap net based. It's very difficult otherwise. And so it's really very difficult to sort of have a mesh size small enough to kind of vacuum up all these little tiny stages, but that's what you'd like to do. In other words, the base of the problem is we're fishing out the adults and not the little ones. The little ones don't come to traps full of adults because of cannibalism. They're not stupid. Well, they're probably stupid, but they can stay away from the adults. But it's also the mesh size of the trap. So there's just structural things that prevent us from vacuuming up the juveniles. And lots of other ways have been thought of, but no one's come up with a method to do that.
And have you eaten any of the green crabs yourself?
Have I eaten them? Yeah, they're okay. I mean, they're small, so I mean, they're not really big enough to have much claw and leg meat. So, the Europeans eat them as bouillabaisse. They basically like chop them up and throw them in the bouillabaisse, and it adds flavor. But they're just not really big enough. They're not ever going to be a commercial value. I mean, so that's been suggested. Like maybe we could start a commercial activity which would help to get rid of them, and we could spend a whole nother hour on whether setting up like a commercial venture for something like this is a good idea or not. But
there's always the risk that you create. It's in a way the human process of suppression and rebound, right? Where you create a market for something, and then there's a demand to keep it going.
There's a demand to keep it going, and if someone's making money in one place, it's like, well, let's introduce them over here, and we can make money also. So there's the concern of spread, and that's been worried about with another species, with mitten crabs. And so it's a bit of a double-edged sword. As I maybe mentioned very quickly, in the Great Lakes, there are places where they're actually funding their suppression program by selling the fish that they capture, literally. Like, they capture, they take them out of the net, they take them to the market, and that helps provide money for the ship time next year. So, there is some sense to a commercial fishery. I don't expect that that's going to necessarily happen with green crabs. So.
All right,
so
we had another.
Sorry, Nikki. I do want to mention that it is 3:00, and some of you may need to leave us. If Ted can hang on for a few more minutes, we could keep answering some of the questions that have come in. I would ask, if you guys haven't already, if you could drop the link to the survey into the chat.
And that will come up automatically for you. When you leave, it'll be in your browser, and you should get a follow-up email from Zoom that will have that link in there, and it would be great to get your feedback.
Great. And I did just want to let everybody know, I think we mentioned it before, that just like in previous years, we'll be posting the recordings of all of these presentations onto the same website where you probably went to register. So you can look for them there too. And it looks like most people are staying on, so let's just keep going with Q&A.
Can I add one more sort of verbal caveat to this, because there may be some people involved in green crab work that's very active in the Pacific Northwest. And one of the things I wanted to make clear is that when the densities are tiny, remember that curve that goes up, it also goes way, way down on the very far left side. And so I want to make it clear that, when you're just starting out, you're not going to get a overcompensation event there. So, people in Washington say, well, gee, should we be worrying about this? I'm like, no. I mean, we get more crabs in one trap in Bolinas Lagoon than they capture in the entire Puget Sound an entire summer. It's like they're getting numbers per 100 traps. So they're not at a point where any of this is going to happen. So that's one consideration. So maybe for the crayfish thing, if you're just getting tiny little numbers in your Southern California streams that are of no consequence, then just go at them. You're probably not going to get something like this.
All right, we had another question from Jorge Bustamante. Would it be possible to develop metrics to assess the eradication feasibility for invasive aquatic species?
Hi, Jorge. Yeah, so, we, in our paper, we sort of lay out what species would be most likely to, be better addressed. I mean, that where eradication would be most effective. So we talk about sort of the conditions in which that should be undertaken. So I think it went back to that one slide. It has to do with, you know, how easy they are to see and how they're distributed and how easy they are to get and their life history. In other words, are there things about their populations that would predispose them to this sort of overcompensation? So yes, we have that. I'm really not trying to sell the paper. I'm just saying that we have discussed that, and certainly species with those characteristics are going to be much more likely to be targets, if you will, of eradication may be effective. Again, I mean, there's a handful of successful marine eradication programs. They're just not very many. And in most cases, they were ungodly amounts of resources that happened and attacked a species very, very early in the thing. So let me just leave everyone with one message, is that eradication is always most effective right at the beginning. I mean, the earlier you can do it, the better. So if you're going to go manage something, don't wait a year, don't dally, just go do it. And all the data from plants and everywhere else shows that eradication is enormously more successful in the early stages. So.
All right, and then we had a question from Doug. What's the actual management? Are all the traps in Seadrift serving to remove a significant amount of crabs, or is it just for monitoring? And is there something else being done for control?
Oh, no, great question. No, every single crab that is in a trap goes away. So that's fully removable. And you may be wondering, well, where do they go? So we actually compost all of those crabs. At the end of the day, we take enormous bags, and there's a farmer in Bolinas Lagoon for whom we go take the crabs. So what we do is we take them, we put them in a freezer overnight, actually 2 days, because it takes them a while to freeze. They're actually pretty resistant. So we freeze the crabs and then we compost them. So literally each and every crab that's in a trap is removed.
So are you then adjusting the number of, like, as you try to optimize, we want to keep the numbers down, but not too low because then they might explode. Are you adjusting the number of traps, or how are you doing that?
That's a great question. We thought about trying to do that. So what we've done is somewhat adjusted the seasonality. In other words, the same effort, you know, in any one given day or week. That way we can sort of continue to monitor, at least be able to compare densities or CPUE values over time. But we do that in a way where we can shorten the season. So what we've done is we've shortened the number of weeks, and that seems to work. So part of this is like feeling it out. So like in 2015 or 16, like, okay, how many traps, how long a period, how many trap days is the right number? So that's, we've adjusted that to some degree. It is a bit self-limiting also. In other words, your trap success declines as the population goes down. So we've been successful so far with our effort. I'm not sure that we actually could predict exactly what that effort should be. So.
And then Ron Clark wanted to know what factors make Bolinas such suitable habitat.
For green crabs, or just, yeah.
I think for green crabs.
Yeah, because of the hydrological isolation. In other words, there's not a lot of flushing in and out. So for better or worse, well, probably for worse, the whatever the recruitment is in there largely stays there, so that it's in a great big enormous fishbowl, if you will, you know, with some limited movement of water in and out, but not a lot. And I think that just means that recruitment doesn't, you know, sort of stays locally.
All right, I think that's all we had for questions.
I want to thank Ted again. I hope many of you are joining us for the next 4 sessions in our series. Tomorrow we've got coming up talking about weeds and what happens after a fire and how weeds invade and how they might then affect fire cycles afterwards. And I also wanted to mention that if you're interested in getting involved in things sort of like this, you can look up some of the links to individual projects, but I also just wanted to give a little pitch for our California Naturalist program, where a lot of people kind of start their careers as volunteers or deepen their knowledge about things they're involved with already. So thanks. And with that,
Thank you, Ted.
Bye, guys.
everyone.
Thank you, everybody. We'll see you